MVVM stands for Model-View-ViewModel, and it's an architectural pattern for implementing user interfaces. It consists of three moving parts. Model, which represents the business objects that encapsulate the data and behavior of application domain. So if you're building an application for finding flights, your application domain model includes classes like flight, location, time frame, and so on. The second moving part is the view, which is what the user sees. In Xamarin World, that means a page. And the third moving part is the view model, which is a model specifically designed for the view. So it's a class with properties that represent the state of the view and methods that implement the logic behind the view. For example, imagine we have a page with a list and a button. When the user clicks this button, a new item is added in the list. If we want to create a view model for this view, we need a class with a property like items, which is an observable collection. So this property represents the state of the view, the state of the page. This class should also have a method like add, and this method is called when we click the add button. So pretty simple, it's no magic. Now you might ask, but Mosh, what you're saying sounds like the code behind. Because in the code behind, we have this observable collection and this add method in terms of an event handler that is linked to the button. Well, not really. Code behind is not view model. As I will show you in the next lecture, code behind is tightly coupled to Xamarin. And this tight coupling makes it hard to unit test this class. So by applying MVVM pattern, we basically take all the code in the code behind, put it in a view model class, and modify it slightly so it has no coupling or minimal coupling to Xamarin. And this way, we get what we call a plain old CLR object, or POCO. That's a class that has simple properties and methods, and we can easily unit test this class. So, as you might guess, you should use MVVM only if you want to unit test your application's presentation logic. If you don't do unit testing, you really don't need MVVM. And it's actually better to write all the code in the code behind. Because as you will see in this section, MVVM involves some challenges, and sometimes you have to write a bit more code. But you do this for a reason. For decoupling your application's code from Xamarin, so you can test it. If you're not going to write unit tests for your application, you would just waste your time implementing MVVM. Let me tell you something. No end user cares how many design or architectural patterns you have used in your code. Users want applications that work, applications that are user-friendly, reliable, and fast. They don't care about MVVM. Nobody's going to give you a prize for using MVVM. So here's my pragmatic suggestion. If you're building a small or even medium-sized application, and you don't plan on writing unit tests for your application, it's perfectly fine to write all the code in the code behind. You don't need MVVM. But as your application grows larger, you would really benefit from unit testing. And that's when you start refactoring your code to make it unit testable. So don't start with MVVM right from the get-go. You would increase complexity without gaining anything. Now, just one thing. Even if you're not familiar with unit testing, I want you to watch this section thoroughly. Because the concepts I'm going to cover will help you have a better understanding of software design. I'm going to talk about interfaces, dependencies, loose coupling, and so on. So watch all the videos, and if some of them are challenging and beyond your level, that's perfectly fine. I don't expect you to walk away and be an MVVM expert. But at least I want you to hear the concepts I'm going to talk about in this section. Because it's very likely that you're going to hear these concepts again in the future. So if you have a background and you heard it once before, it's going to be much easier in the future. With all that, let's get started. Hi guys, Mosh here. I hope you're having a fantastic day or night wherever you are in the world. This tutorial you've been watching is actually part of my Xamarin Forms course where you will learn everything about building cross-platform mobile apps with C#. In that course, we have a more in-depth discussion of the MVVM pattern. I'm going to show you a sample application without the MVVM pattern and then explain why we need the MVVM pattern there and how to implement it. In case you're interested to enroll in the full course, I've put the link for you in the video description. And if not, that's perfectly fine. Have a great day. All right, to see MVVM in action, I have built a very simple application. And if you want to code along with me, download the zip file I've attached to this lecture. So first, let's see what this application does. Here we have an add button on the toolbar. When we click that, it creates a playlist object and adds it to our list. Let's try a few times. Note that the title of the page is dynamically updated, and here we have 4 playlists. Also, below each playlist, we have this detail label, which determines if we have marked this playlist as favorite or not. Now, if I tap on one of these playlists, favorite becomes true, and the color of playlist changes to pink. If I tap it again, it goes back to its previous state. So very simple application. It exhibits a few patterns here. We have a list, we have selection of items, we have adding an item to a list, and we have updating the page title. And here's the source code for this project. So we have models folder, where we have our playlist class, and we also have views with 2 pages, playlist detail page and playlists page. Now, as we work through this section, we'll explore each of these files in detail. Now let's take a quick look at the code behind for our main page, which is playlists page. So here we have an observable collection, which is used as the item source for our list view. Very similar to what you have seen before, no magic. Note that we are setting the item source in onAppearing method. Below that, we have 2 event handlers. One is onAddPlaylist and the other is onPlaylistSelected. Again, the code you see here is very simple, and you have seen several examples similar to this throughout the course. So I'm not going to explain this line by line. But I want to point out a few reasons why this class is not unit testable. The first problem is this onAppearing method. So this method, as you know, is called automatically by the framework when the page appears. Now in this method, we are setting the item source for the list view. The problem with this method is that we cannot call it from our unit tests because it's protected. And I cannot change this to public either, because here we are overriding onAppearing method that is defined in the base class content page. So I cannot call this in a unit test and assert that the item source property of list view is initialized. Now there is a hack around this. We can potentially extract this logic into a public method that we can call from our unit tests. But that's really a hack. It's not the proper way to unit test this code. So we have to revert this back to protected. Another problem is this list view object itself. As you know, this is a private field in this class. Same applies to any other controls that we have in our XAML, and we give them an X name. We'll get a private field in this class. Now, if we're directly working with these controls and the code behind, we cannot write unit tests to make assertions about the state of these private fields. Again, we have to jump through the hoops, we have to expose them as public properties, and this is really messy. Let's look at another example. Look at these 2 event handlers. Again, both of these are private methods. If you want to call them from the outside, we have to make them public. Now, that's not the end of the world, but imagine we had a call to display alert here and ask the user to confirm something. Now, what is the problem here? The problem is that in our unit tests, we don't have a confirmation box. So in a nutshell, the problem with this code is that it's tightly coupled to Xamarin. If we want to unit test this, the first step is to extract as much code as possible into a separate class that we call a view model. And this view model should be decoupled from Xamarin or any other presentation frameworks. And this way, we can easily unit test this, because this view model is going to be what we call a plain old CLR object or POCO. It's a simple class with a few simple properties and methods. It doesn't have event handlers like these private methods here. It doesn't have any references to objects like selected item, changed, event args, and so on. So starting from the next lecture, we're going to refactor this code step by step and extract as much logic as possible into a view model. Ideally, this code behind should be empty, but that's an ideal point and may not always happen, as you will see later.